Yeah, good afternoon. Good afternoon to everyone. Hope my voice is audible to everyone. You can show me a thumbs up if everything is good. Yes, thank you. Very excited, as we know, and Sabki aaj chutti bhi hai, so everyone is present here. So on behalf of Nehru Planetarium, Nehru Memorial Museum and Library, myself, Prerna, I welcome you all for today's very interactive workshop. So Nehru Planetarium, in a very close collaboration with STEM&Space organization, welcome you all for the celebration of Chandrayaan. As we all know that India is all set to create history by landing on the undiscovered side of the moon, which is South Pole, with our Chandrayaan 3. Mission is scheduled for July 14, 2023 at 2:35 p.m. from Satish Dhawan Space Station.
1 minute, Prerna, would you like to show your video? Because we're
I'm opening it, but it's not showing. So
okay.
I don't know. I think some technical fault happened. So
yeah, that's fine, Aryan. If you can share the image till then.
Yeah, I'll just try to do that. Just let me know my video.
Oh, it's showing now. Great, we're seeing you now.
Okay.
Yeah.
Okay. So as we know that mission is scheduled for, now I can also see. Mission is scheduled for 14th July 2023 from Satish Dhawan Space Station, Shri Harikota, Andhra Pradesh. So this will be a great leap for our country in terms of, we talk about space, science and technology. To celebrate this milestone, today in this session, we'll be discussing about the lunar exploration and how Chandrayaan 3 is different. I would also like to welcome our co-partner, STEM&Space, and also like to acknowledge the great work they are doing in making space science education popularizing in children and youth. So about STEM&Space, I would like to share that the mission is to provide the access to space education to every child, regardless of their location. They believe that every child has the potential to become a space leader, explorer, or innovator. I would now like to welcome Dr. Mila Mitra, co-founder, academic head of STEM&Space, to please share some few words and also then timeline, and the team member can proceed with the workshop. Over to you, ma'am.
Hello, everyone. Thank you, Nehru Planetarium and Prerna for inviting us for this, wonderful opportunity. So all of you must be so excited because we've been waiting for Chandrayaan 3 for so long, ever since Chandrayaan 2 made its way to the launch, ever since Chandrayaan 2 launched. And I'm so excited, and I hope you all are. We are getting to see the launch on July 14th, 2:35 p.m. is the launch window. So I hope we all watch out for that. And Chandrayaan 3 is going to contribute some things that Chandrayaan 2 left open. And so today we are going to be discussing the previous missions of Chandrayaan 1 and 2 briefly. And then we are going to talk about what kind of things and technological marvels we are expecting with Chandrayaan 3. And so we'll have a lot of new things to hear. And we are also going to be making a model of Chandrayaan 2. So I hope all of you have downloaded the material. Okay, great. Some of you are showing thumbs up. If not, then just put it on chat and we'll still help you download. And the other thing you can do, if you haven't, is cut out the parts and keep it ready. I'm going to now hand it over to my colleague, Aryan. Aryan sir is going to give the presentation and then walk you through the activity. So have the material cut out and ready in front of you. Okay, so Lavanya, somebody suggested that I should talk in Hindi also. Aryan, just keep that in mind also. Repeat the lines sometimes in Hindi. But yeah, we are looking forward. Abhi Chandrayaan 3 launch hone wala hai. We are standing at that moment. Chandrayaan 3 ka launch July 14th ke liye planned hai. So Aryan, you can take it over and share with the kids the excitement of Chandrayaan 3.
Thank you so much. Hello, everyone. How is everyone doing? All good? Yeah, should we start today's session? Are you all excited? Give me a double thumbs up if you all are ready. Okay. So far we have seen India excelling in the mission of Chandrayaan and lot more missions. Reaching moon is one of the targets that has been from long back. Let me just share my screen to begin with it. So as it is already shared, Chandrayaan 3 is launching this week itself. Like, you just wait for 2 more days and the news will come how the mission goes. It's really exciting moment for each one of us, because if you were following Chandrayaan 2, it's like, your heartbeat is even stronger as the date that's get closer. I hope you all can see my screen.
Yes.
Yep. Okay. So yeah, we are celebrating Chandrayaan, and I'll be talking about all the Chandrayaan missions, why going to moon is so special, so important, how is it going to help us in future missions as well. Okay, India so far, you have seen that we have sent missions to moon, missions to Mars. In none of the missions so far, humans have gone in space from India, have they? So probably this mission, Chandrayaan 3, is leading in that direction too. Where is the connection? Let's find out all about it in today's session. So it's an upgraded adventure to the lunar surface. The question that generally comes is, why Chandrayaan is so special? Let's find out through a very interesting video, so all eyes are on the screen.
Moon, the spatial object that has captured hearts and imaginations for as long as we can remember. The key to our past and the way to the future. The world has always been fascinated with the moon, and we have paid our closest neighbor many visits over the past century. 1959, Soviet Union's Luna 2 was the first man-made object to reach the moon. 1966, Luna 9 made the first ever soft landing on the moon. And in July 1969, the world held its breath as Apollo 11 became the first manned mission to land on the moon.
That's one small step for man, one giant leap for mankind.
Between 1969 and 1972, 24 people traveled to the moon, and 12 of them could come back to tell us what it was like to stand on new ground. And as we watched all of this in awe, we knew we had to leave our mark too. On 22nd October 2008, India turned a new leaf in her space program. The Chandrayaan 1 was launched. During its magnificent tenure, the mission reported a remarkable discovery. We found water on the moon, and nothing was ever going to be the same again. Chandrayaan 1 gave science a whole new perspective, drawing attention and awards. But for us, the journey had just begun. It was our first step in exploring a world that explains our own. It was the start to answers mankind has always been asking. For over 10 years, thousands of people from across the country came together for one dream: India's next big expedition. We're all set. Are you?
So you see, several missions have tried to reach the surface, and the history was made in 1969 when the very first human landed on a very alien ground. For the first time, we were looking at something which is so, very different from Earth. The soil is different, the environment is different. So that's how the journey began. Neil Armstrong, famous word: one small step of a man, one giant leap for mankind. And it is really a giant leap. So India is also not falling behind in this race to the moon with Chandrayaan mission. I hope you saw that 24 people tried to land there. 12 of them were able to reach and experience that surface. What do you think happened to the rest? All on you to explore. Okay, so Chandrayaan 1 had a major discovery that time. India had discovered water on the moon, and that's how it led to Chandrayaan 2 and now Chandrayaan 3, and maybe in future there will be Chandrayaan 4 as well. So let's these all missions that we are talking about is from ISRO. Everyone has heard about ISRO? Raise your hand if you all have. ISRO? Yes? Everyone has? It's the Indian Space Research Organization that from India, it handles all the missions like Mission Mangal. If you have seen, you see how many ups and downs are in the mission. Even Chandrayaan was no different. Lots of, improvements were needed. Lots of efforts were needed in this mission as well. So if you see the name Chandrayaan, it's very Indian originated name, right? Chandra, that means the moon, right? All of you call it Chandrama. Sab bolte hain Chandrama, yeah? Or you say Chanda Mama. What do you say? So it's Chandra, that means moon, and Yaan is the craft. The vehicle to the moon was called Chandrayaan. So सबसे पहला मिशन जो हुआ था, that was Chandrayaan 1, India's first mission to the moon. और ये launch कब हुआ था? ये launch हुआ था October 22, 2008. The launching site of India is Sriharikota. This is from where all the missions are launched. And the rocket used for the launch was PSLV, okay, Polar Satellite Launch Vehicle. Now, this was used in Mission Mangal also. If you remember or you have seen the movie, this particular rocket was used to launch Mangalyaan as well. That time, other countries were saying that India might not reach Mars with such a weak rocket, because this rocket is not so powerful as compared to the rockets and technology that other countries have used. But India made it with this rocket because there is a different technology, different kind of strategy that we use. In this particular mission, there were two main components, orbiter and an impactor. Yeah. So here you see, this is Chandrayaan 1. The space engineers are working on this Chandrayaan 1 here in the lab. And what's an orbiter and impactor? This part you see is an orbiter. Any ideas? You can write your answers in the chat. Those who know what's an orbiter, quickly, let's see who knows what's an orbiter. Many people have joined us on YouTube as well. You can also answer us there. So you see participants are here on the Zoom as well as on YouTube. What's an orbiter? Let's see. I don't want a very big answer. Small answers will do. The name itself gives you the answer, orbiter. It comes from a word, orbit. Yep. Okay, so Arna has replied, I think the part that orbits a stationary object. Okay, good, Arna. All of you can try, okay? Do not feel it like any particular regular session. You all are free to interact, free to pose your questions. Some of the questions will pick an answer by the end. Some of the questions will already be answered by our experts who are already on the chat with us. So orbiter, yes, you are right in a way. Orbiter is actually any spacecraft that is orbiting a celestial object. So in this case, orbiter is orbiting which celestial object? The moon. So that was Chandrayaan 1's orbiter. And it had a second component called impactor. That means it has to go and impact on the surface. Its name was Moon Impactor Probe. This you see is the Moon Impactor Probe, and it's getting attached on the top part here of the orbiter. This side is the orbiter and this side is the impactor. So both were attached together. So, the impactor, everything went very successfully in Chandrayaan 1. The impactor was released. You see the impactor is getting released here from the orbiter and it's descending down towards the surface, and its targeted area to hit was South Pole. South Pole is one of the most unique areas. You see, none of the other spacecrafts or missions had tried to aim for the polar areas of the moon. Mostly it's all in the equator. But from the starting, India has targeted the South Pole area, and the impact happened on November 14, 2008. With this, India became the fourth nation to place its flag on the moon. Before that, US has been there, China has been there, Russia has been there. So India became the fourth nation. And with this particular mission, as I have already talked about it, we discovered water on the moon, and nothing was going to be same again. Everything changed after that, because you see, if we have found water there, we also plan to settle on the moon. We also plan to explore the surface. Its moon is very much rich in mineral. So this particular area is a big spotlight now. If anyone is studying the moon surface. So with this proud moment, there was the second mission, that is Chandrayaan 2, India's second mission to the moon. So ये कब launch हुआ था? ये launch हुआ था July 22, 2019. You see, this wasn't the launch date before. Before it was around July 14th. But जब launch हो रहा होता है, every last moment, everything is tested. So last time, जब everything was set, fuel भरा जा रहा था in the rocket. So there was a problem that was detected 1 hour before the launch, just 1 hour before the launch. Can you imagine? So it was cancelled that time. And then later on, it was launched on July 22, 2019. You can see the launching site. It's once again the same Sriharikota. That's the launching site of India. But इस बार क्या किया हमने? इस बार हमने और powerful rocket use किया. The rocket name was GSLV Mark III. Okay, it's a very powerful rocket. Iska nickname, everyone has got a nickname, right? This rocket has got a nickname of Bahubali. It can lift lots of weight. Okay, that's why this rocket is special for India. And if I talk about all the bulk landings, like Apollo mission ka naam suna hoga. Apollo was the mission jisme Neil Armstrong, Buzz Aldrin, they went down on the surface. And many other missions, other Apollo missions also, Apollo 14 and all, they also landed on the surface of the moon. But where did they exactly land? They landed on this area. You see, this is the equatorial region. Nobody is targeting the polar areas. Okay, landing on equator is still, it's a good location. It has got good exposure of sunlight if you want to land on. And, missions do work on solar panels and all. So good visibility is also there. But targeting polar areas, they are really dark areas. Okay, यहाँ के जो soil है, it's undisturbed. We all know that on moon, there is no rain, no air, no human disturbance. So, and these areas are not even getting proper sunlight, the north and south, the polar areas basically. So if you're studying the soil from there, the elements, the composition, you're actually looking back in time. You're looking into how the composition was when the solar system was being formed. Okay, so it's good that you can have that kind of knowledge just by studying the closest celestial object. But landing on these areas gets equally difficult. Very challenging, actually. So Chandrayaan mission, you see, from the beginning, we discovered water, that also in the South Pole area near a crater called Shackleton. And with Chandrayaan 2 also, this was the targeted site. You see, there is a crater called Simpelius. Next to it is a flat surface. And that's where Chandrayaan 2 intended to land. See, this mission was very different. The first one was an impact. This time, we wanted to make a soft landing, descend down very slowly in a very controlled manner. And that's how one major difference, one major achievement of new technology could be done. So that was the interesting objective in this mission. If I compare Chandrayaan 1 and Chandrayaan 2, you see Chandrayaan 1 had an orbiter, but Chandrayaan 2 had 3 components: an orbiter, a lander, as well as a rover. What are all these 3 components? Let's talk about them. So orbiter, I think everyone is clear by now. Yes, sabko pata orbiter kya hai? A spacecraft that is going to orbit around. So Chandrayaan 2's orbiter is still, we are having our session. This orbiter is successfully orbiting around the moon. Okay, at how much height from the surface? At 100 kilometers around the moon. Okay, and it has got different kinds of payloads. Have you heard about payload? Anyone who has heard about payload can quickly write your answers in the chat. What do you understand by payload? There are different kinds of payloads attached in a satellite. For instance, if I say, all of you have took selfies. Have you not? On day-to-day basis, or when you're traveling to good location, you're like, oh, let me take a selfie with that. So when you're taking a selfie, there is a camera in your phones. Yeah. So you can say that it's kind of a payload. If you attach such a camera on a satellite, it becomes a payload. A payload is science experiments, all the science instruments, the experiments that you attach to a satellite. I can see Dishita has given some answer. That's good. So payloads are all the science experiments like cameras, the sensors, all those things that you add to it are called as payload. Let me clear this annotation. So this particular orbiter had a very special kind of payload. Let me tell you what payload was that. There was a payload which was called OHRC. Its full form is Orbiter High Resolution Camera. So it's just like any camera, you can say, just for our own understanding. So I'm going to show you one of the pictures that OHRC had returned. You will be amazed to see how clear it is and how much detail is in that image. Okay, let me just move to that part, as it creates one of the sharpest images of the lunar surface. And it has clicked one picture on September 5, 2019 of the southern area. There is a crater called Boguslavsky crater. It's 3 kilometers deep. And I'm going to zoom in into this smaller area. You see this smaller area over here? This is where we are going to zoom into right now and see. Can you watch it now? How clear it is, how beautiful it is. You can actually see even the smallest of the craters. They are just less than 5 meters in diameter. If you know what is a crater, the space rocks keep hitting the surface of the moon. It does not have the privilege of atmosphere. So there are so many craters there, smaller ones included. You can clearly see in this particular image that orbiter has, gave back to Earth. Other than that, you can see even the small rocks and boulders, which are just 1 to 2 meters, okay, in height. So with OHRC, you can actually create a very, very detailed map of the moon. So that's how you can just study it from this, from being on Earth by making such a map. It's called a topography map that can help you study it very clearly. So that's how you can say that Chandrayaan 2 orbiter is really a success. The second component in this particular mission was the lander. The lander was called Vikram. Okay, why did we call it Vikram? There is a reason behind that also. It's not like our classmate was Vikram and we just call it Vikram, right? So Vikram, you say the founder of Indian space program was Vikram Sarabhai. Yep, I hope many of you may know this fact, right? So to honor his name, the lander was called Vikram because this was also a very new thing that India was trying out. So this lander spacecraft, what is a lander spacecraft basically in general term? It is supposed to land at a place. And when it is landing, after that, it cannot move. So you need to know where you are landing. You need to know which area you want to explore. So this Vikram lander was intended to make a soft landing. And again, which location? The South Pole. Again, we were targeting the South Pole area where no other mission had ever tried to land softly. Okay, so this was something new that India was trying with this mission. It was a very unique mission. And inside this lander was the third component, and that's a rover. Rover in general terms, if I say like you have land rovers, it goes from one place to another, right? So in a similar way, when you send a rover to other celestial objects, that's your rover in space. But it has to be different because the surface is not so even like Earth. Have we gone and built roads there? No, right? It's quite uneven surface. So even the wheel design is different. You see, it's a 6-wheeled rover. It has got solar panels. It also has got payloads so that it can do some experiments while it is moving on the surface. So how was this entire thing planned? How was it to be executed? Let's watch it out through a small, very interesting video over here.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
So here we saw what was the plan of Chandrayaan-2 mission. Okay, we have seen the rocket was successfully launched. And if you noticed, the Chandrayaan had to make multiple orbits around the Earth. It's like Puri concept that's explained in one of the movies. So whenever the spacecraft is like close to Earth, you just use the thrusters and increase the speed. And that's how the orbit size keeps on increasing. And finally, the orbit size was so big that it actually reached to the moon and was trapped with moon's gravity. Okay, that's how it reached from Earth to moon. And later on, what it had to do was, when it was 100 kilometers above the surface of moon, the orbiter and lander had to detach. This also happened successfully. The orbiter and lander detached. So orbiter has given us wonderful results. Do you think the lander landed successfully? What do you think? Let's see, yes or no. Did it happen all the way we saw it? This was the plan. Any response from your side? Okay, I see some answers here in the Zoom chat.
They mentioned.
So there has been problem with the lander in Chandrayaan-2. You see, definitely it was disappointing. So what the graph that I'm showing you right now was being displayed in the mission control room, where all the scientists, engineers, even the public, some of the public figures were sitting there and watching it. So what is this graph showing us? This graph is showing us how the lander had to go down slowly and land on the surface. You see this blue line curve? This is how the lander had to go down. So as the lander was going down, it was following the path. But at certain points, there were software glitches and connection issues. You see, when a lander is going down on a surface, it goes down with too much velocity. The speed is too high. Yeah, you need to slow down that speed. And that speed was being controlled from Earth. Did you notice the thrusters in the landers which were getting fired up? And what is that used for? That is used for slowing down the speed. So we could not give the control for that. So we lost the connection not just once, but multiple times. It was off course. You see the path has changed. But when we gained the connection, its path was once again fixed. But later, the communication was totally lost. We didn't know what's happening, and the graph just showed a dip. Okay, it just fell down. That's how the graph was. And it was very disappointing for everyone. Every mission, too much effort is by the engineers, by the scientists, the funding is involved. So many things are happening in the mission. So at this point, you see, definitely people were thinking that, okay, why didn't we land? Everything in science is an experiment. This leads to a new learning. But that time, since it's happened, definitely there will be some disappointment in our hearts. So later on, what happened is an engineer from Bangalore tried to find out what happened to the lander. Okay, so he compared the image of before landing and after landing and found that there was some disturbance in the soil in the region of where it had to land. Okay, it was literally like finding a needle in a haystack. You see, a lander is a very small body when you're talking about a big moon, and looking at its landing site, how the soil was disturbed. He did that. And in fact, many of us can do that. These images are available. So even a random person can do such kind of a check. So this is how we finally knew that lander had crash landed. But what should we do when we fall? Should we just stop right there? You should this time stand up and run even harder. And that's what ISRO is doing. The third mission to the moon, and that's the upcoming mission, Chandrayaan-3. And as I said in the beginning, this is happening like 2 days after, on July 14th, it is scheduled to launch, and all eyes on this mission. As Chandrayaan has done wonderful jobs, wonderful discoveries, like we have found water, we have a better quality images upcoming. None of the other spacecrafts, be it from NASA or other space agencies, are giving such clear pictures. So definitely all eyes are here on this Indian mission, Chandrayaan-3. This mission is building on the success of Chandrayaan-2. We saw some ups and downs in that mission. So how is this mission taking Chandrayaan-2 ahead? So we saw that in Chandrayaan-2, we had 3 components: orbiter, lander, and a rover. So in this particular mission, there are two main components, that is a lander and a rover. There is one more third entry. I'll just show it to you. It is just rotating for a while. So there is a third component involved called propulsion module. Okay, PM in short, not the Prime Minister, remember, it's propulsion module. And these three together will be making it to the moon. Propulsion module will be used to take the entire components of Chandrayaan 3 to the moon. The process is very similar. We'll be orbiting around the moon and, we'll be orbiting around the Earth first and then reaching to the moon. Yeah, the slide is working now. Let me just show it to you. It's a similar manner. We'll be making around 5 orbits around the Earth and then reaching to the moon, and the propulsion module and the lander module will detach. The lander has to land, so definitely it will go towards the landing site. And once again, which side do you think are we targeting to land on? Are we just going random, or since it's completing Chandrayaan 2, the targeting site is once again the South Pole area. I'll just like to highlight one part over here. You see, this mission, Chandrayaan 3, is actually an indigenous mission, means the lander, the rover, the propulsion module, whatever component I'm talking about is being designed in India. It's being made in India. So it is not just taking us to the moon, but also showing the, it's showing the technology improvements that India is being through. It is developing and demonstrating the new technologies that are required for interplanetary missions. Okay, so if we are successful in these kind of things, we can actually target for such things in the future missions to land on different planets too. So the lander will have the capability to soft land once again and at a very specific lunar site, and it will deploy the rover. Okay, so that's how this mission is going to be. So Chandrayaan 3, India's third mission to the moon, it's getting launched on July 14th from Sriharikota. You can note down the time. It's happening at 2:35 p.m. IST. Okay, so at 2:35 p.m. on July 14th, the launch will happen, and this time the launch vehicle is LVM-3. It's the same actually. GSLV-3 is also called as LVM-3. And this particular thing has got 3 components now: lander, rover, and propulsion module. Here you see is the image of Chandrayaan 3. It looks very similar to Chandrayaan 2, does not it? Here at the top is the lander. Inside the lander is the rover. And this bottom portion that you are looking at is the propulsion module. Okay. So as I have told, it is going to land on the South Pole. The lander, a lot of improvements have been made. Last time we had a failure, but this time all those shortcomings are, taken care of. The lander will have 4 thrusters and even stronger legs this time. You see, even if it hits the surface with a little bit more velocity, the stronger legs will be able to hold, withstand the shock that it faces as it lands down. So these are some improvements done. There are bigger solar panels now. Other than that, you see, when a lander is going down in the video, if you notice, it was scanning some area. Yeah, it has to scan the landing site so that it can go to it can land on a particular position. So last time we had, you see this camera, lander hazard detection avoidance camera, LHDAC in short. This is also one of the payloads of the lander. So last time we only had one. This time, to have a better visual, we have 2 such cameras, and there are multiple sensors attached to avoid any such failure that happened in Chandrayaan 2. So this is how this mission is more improved version of Chandrayaan 2. It has stronger legs, more sensors and cameras to facilitate the landing in a better way. So there are different payloads. I'll just talk about some of them. Like it has got one of the payloads that's called Rambha. Then there is a Chaste particular payload. Its full form is Chandra's Surface Thermophysical Experiment. So this particular payload is going to measure the thermal properties, means heat signatures of the lunar surface near the polar regions. So we have not done that yet. As I said, we have not landed on the South Pole. So this will give us a new insight, definitely. There is another instrument called ILSA payload, like you can see over here. The full form of ILSA is Instrument for Lunar Seismic Activity. On Earth also we have seismic activities, right? So it's basically going to measure the seismicity. That means the vibrations happening on the surface, how the surface below, all those things it is going to study a little in detail. There is one also passive experiment that's supposedly by NASA, that's LRA, measuring the range of the moon and Earth, adding another dynamics to it. Then I've already talked about it. Okay. Then the next component is the rover. Now, rover, as you said, is going to move on the surface. So definitely it will give us more new knowledge as it moves on the surface. It is going to do some in situ experiments, means on-site experiments as it is moving. So some hardware and software changes have been made in the rover. So even the rover is upgraded now. So this rover will communicate with the lander. If I show you the lander body, you see over here, it has also got different payloads. It has the receiving and transmitting antennas here attached on the solar panel that will help us power up this entire rover. There is a solar panel hold down, means first the solar panel will be closed. As it comes out, the solar panel opens. It has got a warm electronic box so that you see, again, if you are near the South Pole area, the sunlight is less. It needs to warm up to keep the instruments warmed up. So there is a electronics box for that. Then the mechanism used for the rover is called rocker bogie. As I said, we can't just take our normal cars there and it will start running. It might just trip. Yeah. So a different kind of mechanism is used for the wheels also. This is one of those types called rocker bogie mechanism. This particular rover basically targets to study 2-3 things. Like it is going to study the chemical and mineralogical composition. And also it would be studying the elemental composition, like the magnesium, aluminum, iron, all those compositions it is going to study in the soil. And one new element that I was talking about before, that's the propulsion module. Okay, kind of looks like the orbiter design, yeah, of Chandrayaan 2. So it looks like that, but it's different. You see, the propulsion module this time has got one very unique payload. It's called SHAPE. The full form is Spectropolarimetry of Habitable Planet Earth. You might be confused. It's a long abbreviation there. So what is the SHAPE doing? SHAPE, once again, it's fixed in this propulsion module, which is orbiting around the moon at a height of 100 kilometers. From there, it is studying the light coming from the Earth. This is a very unique perspective now. We have reached moon, and moving around the moon, we are studying the light coming from Earth. So if we understand the signatures of light coming from the Earth, this will help us study the exoplanets and is there life on exoplanets. So with this particular payload, India in future is actually also targeting to study the exoplanets, you can say. So a lot more interesting things are upcoming, and they are dependent on the success of this mission. So I'll say these are some of the major objectives of the mission. We are trying, ISRO is trying to demonstrate the safe and soft landing on the lunar surface. It is trying to demonstrate, how the rover works on the surface, does it move properly, study everything properly, and is able to conduct the in situ scientific experiments. That means the on-site experiments as it moves on the ground of moon. So for all these things that ISRO has done, for all the efforts ISRO has put, we wish ISRO all the best. Let's all of us wish ISRO all the best for this Chandrayaan 3 mission, and fingers crossed for everything to go successfully on July 14th at 2:35 p.m. Keep your eyes up for that. And with this, it's time for us to make a model of Chandrayaan 2. I hope we all are ready and excited. Yes, you can show me your excitement in the chat. Are we all ready to start with model making? Do we have all the parts cut and ready with us? Yeah, so those are who are in the Zoom chat, give me a thumbs up. Those who are on the YouTube, you can also write, yes, we are ready with the materials. Let's see. I'm going to show you what do we need right now. So we are going to make the model of Chandrayaan-2. We will be making two components of Chandrayaan-2. One is the orbiter and the second one is the lander. Lander design is pretty much similar to Chandrayaan-3 also. So in a way, you can say that it's two in one. You will need the cutout of these materials. We will need 8 toothpicks. We will need clay. See, foam pieces are written over here. Instead of foam pieces, you can use clay, any normal Play-Doh, all those things that you use. We will need sellotape or Fevicol. I hope we are ready with the materials. Sure. So even if you miss any of the steps, please do not worry. It's a YouTube live. The recording is always going to be there. You can watch it and redo the steps. Try to understand at least how the model is getting made and follow along as much as you can. So I'm going to show the very first step. Please have eyes on the screen. So first up, we will be making the orbiter body. The orbiter body.
Aryan, you're still sharing the previous presentation.
Sorry. I'll just stop share and share it once again. Thanks for the reminder. I hope you can see my screen now.
Yes.
Okay. So here is somebody has asked me to repeat the materials. So I'll repeat the materials once again. So for this activity, you will need the cutouts. These are the cutouts. We are making two components. That's the lander and the orbiter. We will need 8 toothpicks. Here it's showing foam pieces, but you will need clay instead of that. Okay, any normal clay that you play with, and then Fevicol or sellotape. These are the material requirements. I hope we are ready now. Let me show you what are we going to make first. The very first part is orbiter of Chandrayaan-2. So orbiter of Chandrayaan-2, there was a cylindrical structure. If you noticed, this is where the lander and the orbiter are connected together. Okay, it's like an adapter system there. And there was a box below. On box, there were all different types of payloads. On one of the sides, there was a big solar panel, and another side, a solar panel that was coming out of the orbiter body. So this is how our structure is going to be like: a cylinder, a box, and a solar panel. So let's start. First up, take this part in your hand, everyone. This gray color part, and has got a circle attached to it. Some of you may have took out the circle, I believe. Have you? Anyone who has cut the circle out from here?
As of now, no. It is still attached.
Okay, good. In just in case anyone has took it out, no problem. Just keep the circle with you. Let's see what to do with this. This will make something like this, the image that you see on the side. Okay, a cylinder. So here I'm playing the step now. Okay, on one of the sides of the cylinder, there's a red line. Along that, you just apply some glue if you are using glue. Bring the other side and overlap on the top like this. Okay, and just hold it for a sec so that it sticks. If you're using sellotape, just bring the two ends together and put a sellotape. Make sure you are overlapping the two sides just till the red line. Do not overlap too much. I'll repeat this step once again for anyone who has missed it. We took this cylinder, we took this cutout. On one of the sides of the cutout, there's a red line. So inside that red line, we have applied glue. We took the other side and we overlapped till the red line. Okay, you can overlap till here, and you can apply sellotape also, like 3 small sellotapes you can stick like that, and it will make a cylinder like this. If you're using glue, do hold it for a while. Those who are done, please show it to me. Let's see. Okay, very good. Manan has done. Atharv, Suhani, Waish has also done. Wonderful. DPSG Palam Vihar. You can just rename if possible. So good. Many of you have finished it. Wonderful. Why are so many videos off? During activity, if possible, you can keep your videos on and try to show it to us. Very good, Karthik. Arshdeep, done? The audio isn't coming. I'll just repeat. All we have done is on one of the sides where the red line you see, till there we have applied the glue. And we have brought the other end and overlapped it. Those who are with us on YouTube, do not worry. You have to follow the same step and be interactive. As soon as you are done, write in the chat that, okay, I'm done. Let's see who has done. Any of the YouTube participants has finished it or not. Anyone who doesn't have the materials, do not worry. You can do this later as well. Are we all done with this? Okay, I see. Many of you are done. So I'm going to show the next step now. Please look on the screen. I see Revati from YouTube has replied that she has also done. Great. Nalika has also done. Very good. Let's see the next step now, since many of us are done. So on this, you see there are some triangular cutouts that are coming from both the sides, right? So first up, we are going to work on the side where the circle is attached. Okay, so let's see what to do. We will fold these triangles downward like this. Watch the entire step and then you can do. Okay, please watch the entire step. First up, what we have done is on the side of the circle, you see these triangular pop-ups. We have folded them inwards. It is not completely folded. It's kind of like half folded. And then what we will do is we will apply glue, just a drop of glue on all these triangular cutouts, and the circle will rest on top of it like this. Okay, I hope this step is clear. Those who have understood, please go ahead and do this. Those who have not understood, please watch the screen once again. So first up, what we have done is the cylinder that we created, you see this triangular cutouts. We have folded these triangular cutouts like halfway, not completely in the inside, like half. And then we have applied glue on all these triangles and then close the circle like this. I hope we are done now. It was a very easy step. Wow, I see so many of you have done on the YouTube chat as well. Let's see here. Some of you are doing, some of you are done. If you are using glue, do give it some time to dry off. Very easy step. Those whose videos are off, at least you can give us a thumbs up. Yeah, let's see. I can see Naisha, Swara, Abir. Okay, good. Kaira, Karan, Dishita has given me a thumbs up. Good. Is everyone done now? Okay, we should go to the next step now. Okay, even if you're not done, it's okay. You just understand the steps. Even after session, you can do, because I'm not going to take your model. Okay. All right, let's see the next step. The next step, you see this cutout now. Yeah. Everyone take this cutout with you. Are we all ready with this cutout? So yes, that one you are showing. Very good. So this cutout will help us make a box like this that you see on the side. This box will have one side open. Okay, the three sides are covered, but one side will be open. This big thing that you're watching is a solar panel. It's a large solar panel that is attached on the orbiter body. All right. So these red lines that I'm showing over here, this is from where you need to fold the paper. Okay, let's see how. This straight line, second, third, from all these places, we will fold it, and fold it backwards, means towards the white side. You see, one side is printed, the other side is white. We are folding all of them towards the white side. You will see some red lines drawn over there from where to fold. Do you all notice that? That's where you need to fold it from. Done folding? If anyone has worked with papers before, you might have figured out how to stick it or take the next step forward. But do watch the step here on the screen so that you're aware what to do first and avoid any mistakes. I'm playing the video once again, just to clear any doubts. There are some red lines on the paper. You have to fold along those lines towards the white side. One side is printed, the other side is white. You need to fold it to the white side, the blank side. All right, I think we are done with this. Now you see this small portion that we folded, this very small portion. This is where we will apply the glue. We will take the other side and stick over it. I'm going to play the video so that you understand. You see, this is the smaller flap that we just folded. On this smaller flap, we will apply the glue. We will take the other end and stick on top like this so that the white part gets hidden. Okay, the white area where we applied glue, it gets hidden as soon as you stick the other side. Easy. I hope nobody is getting confused. Great. Wow, I see Karthik has made also. And you are sharing some good facts behind, I see. Earth facts, yeah? Wow, it's like a news channel. I'm watching you. Others, are we done? Very good. Arna, that's correct. Arshdeep, are you done making the box? Try to follow along, everyone. Okay, next step, eyes on the screen, please. Whether you're doing or not, you must understand what to do next. Look here. Now, one portion is coming out. You see, one of the flaps is out. So wherever these red lines are, we will fold along those red lines also like this. Basically the white parts which are coming out from three sides. There's the first fold, the second fold, and now the third one. We have folded it inwards once again. This will help us close the box from one side. We will apply some glue on all these white cutouts. And we will insert it inwards. Understood? The one part which was coming out, we have just worked on that part, and you see this box is made now. Those who have understood, please continue. Those who have not, please watch the video again. These white flaps which are coming out from three sides, fold all of these three. There is one more fold needed where the solar panel is attached to this flap. We will apply the glue on this three white portions which are coming out. And then insert it to close the box from one side. In case you are using sellotapes, just use 3 pieces of sellotapes to secure it from all the 3 sides. Let's see how many of you have done it. Okay, good. Once again, I see many of you have done it. Shilpi ma'am has done it. Karthik, Suhani, Atharv. Who else? Parth has also done. Manvi has finished. Very good. Kyra gives me a thumbs up. Very wonderful. On YouTube, who all have done it, please let us know. We have made a cylinder with which we have closed with circle on one side, and now we have made a box. See, we are making the it part by part. In reality, also, the entire modules are made part by part only. And you may be wondering, why are we making a paper model? You see, generally, when any satellite is made, it's not like they make it directly. They make a simulated version. They make a smaller miniature version. Even if you have seen any society buildings, when they're making, they do plan it with a miniature version. So something like that. So first up, this is a step. This is also engineering. It's made, it's understood whether the size is okay, whether the parts are fitting okay. All these things are checked beforehand. So that's what you are doing. It's kind of an engineering. The box is made now. Now let's move to the next step. Eyes on the screen, please, everyone. Now we will take both the parts that we made right now, the cylinder and the box. You see the cylinder, one side we have already closed, right, with the circle. The other side, we will fold the triangles once again, and we will insert the cylinder inside this box that we have made. How? Let's watch it. Take the cylinder, fold the triangles like this. It will be folded halfway only, once again, not completely inside. You can see it lying on the top, yeah? Then we will apply glue on these triangles. And insert it inside the box like this. Okay, so that they stick together. Got it, everyone? All we have done is we have folded the triangles on the other side. We have applied glue on it, and we have sticked it in the box that we made. Good. Adva has done it. Kartik has done. Suhani has finished. Parth, very good. Atharv. Arshdeep has also finished. Kaira, Samiksha, very, very good. What about others whose videos are off? Are you guys doing? Hope nobody is sleeping, yeah? At least give me a thumbs up for that you are awake. Okay, good. Dishita is awake. Okay, any doubts so far? All good? Okay, so now that we have made this part, what do you think is missing in this orbiter? Anyone? What is missing in this orbiter? Good, Mrinalika has done it, attending us from YouTube. Yeah, Adva is showing something. What's that? It's a solar panel. Yes, we need to attach the bigger solar panel to it. So here is the solar panel. Everyone take it in your hands. Let's get ready for the next part. Okay, so in this one, from the center, you see where the red line is drawn right now? From the center, we will need to fold it. Let's watch first. From this red line, we will fold it like this. The printed part of the solar panel should be outside. Okay. And after folding, what we will do is, on this white rectangular part, we will apply glue and stick them. Notice one thing, we are not applying glue on this handles of the solar panel. We have just applied glue on the big rectangle portion. Okay. No glue on this handle part of the solar panel, just on the bigger portion of the solar panel. Got it? I'm playing the video once again. First, we folded it along the red line. Then we have applied glue. And then we will stick them together. So solar panels are one of the major things that helps a mission run. Before, battery dependent missions were there and it was really difficult. So solar panels help us generate and store energy. That's really a good step that make missions last longer. Wonderful. Many of you are finished now. I'm showing the next step, how to attach it with the orbiter body. So in this solar panel, on these handles, you see, we will fold the handles from half of it, like where the red line is. You see the red line? From here only we will fold them. We will not fold it from here. Let's see what do I mean by that. This is the entire handle part. From halfway, we will fold it like this. It will be like T. One of the flap will open on one side, the other flap will open on the other side. Both of them are not opening on one side. Okay, it looks like T. If you see in this image, one is up, one is down, one is up, other is down. Like that, you need to fold it. I hope it's understood. Wonderful. Now we need to attach this to the orbiter body. So in this orbiter body, everyone notice that on one side, there is a huge solar panel. Do you all notice that? On this side, there is a big blue color solar panel that is rising up. Everyone notice that? Now, opposite to that, you will see there are two black small lines marked. Check out on this box that you have. On one side, there's a huge solar panel. On the other side of the solar panel, opposite to it, there are two black lines made. That's where we are going to stick our solar panel. All right, let's see how. So here we will apply glue on these white areas and attach it this way. Okay, make sure you're attaching the solar panels like this only. You can see in the image also finally how it is looking once it is attached. If the solar panel is going down for you like this, you add something below like double-sided tape or something so that it stays there, or maybe a toothpick inside the solar panel that makes it go straight or something. That part you can do later. For now, just stick it like this. Done. Manasvi has done. Very good. Suhani has also finished. Good, Manan. Yeah, it's looking very nice. All of you are doing good work. Good, Samiksha. Very good. How about others? Are we done? Very good, Manvi. Atharv has also done. Okay, now we have made the orbiter. Now we are going to make the second component. But before we make the second component, anyone needs to name it in the chat. What is the second component we are making? Let's see who remembers. Who remembers the second component of Chandrayaan 2 mission that we are going to make right now? Quickly in the chat. Hurry up, hurry up. Lander. Okay, there is a spelling error, but it's okay. I understand your emotions here. It's lander. What was the name of the lander? From YouTube participants as well. Let's see who remembers it. The name of the lander. Vikram. Yes, very nice. The name of the lander was Vikram. So let's make the lander now. The lander, how will it look like? This is how it is going to look like. It has got legs. Below we have added clay because it has got a sponge kind of structure for the soft landing down there. And this time the legs are even more stronger so that it can hold down the increased velocity when it is landing. And the lander upper part is also like a box that holds all the payloads on the outer side. Like I was talking about payload like ILSA that will measure the seismic waves of the moon, or other components that will measure the thermophysical activities like the heat on the surface. Everything is attached on the outer portion of the body, while the rover is inside this particular lander. So let's make the lander. We will be using this cutout to make the lander. I hope everybody has this part. Just one thing you will find different in yours probably. The black part below is not attached to it, right? Do you have it attached or you have it separately? You have it separately. Oh, it's attached. Okay. So very first step, what are we going to do is, you see the white dots these white dots, there are total 8 white dots here. We will make holes with toothpicks in those 8 white dots. Watch it. Using the sharp end of the toothpick, we will make holes in these white dots. This will help the legs of the lander. We will insert it later. Right now, you just need to make a hole and take out the toothpick. The toothpick does not need to be attached there. Be very careful while using the toothpick. If you are not comfortable with it, take some help, or else you can put an eraser or something below it and you can directly, use the toothpick and pierce through it. Okay, it will be more easier and comfortable. So total 8 holes are to be made. Very good. All those who have answered in the YouTube chat also, Vikram Lander, that's correct. Has everyone made the holes? Good participation in YouTube chat also. Very good. I see Prachi, Archana, Sunhat, many have replied. Very good. Keep responding, make it interactive. Keep asking your queries too. Some of the questions we can address later by the end, depending on time. Are we done? Okay, Samiksha wants me to wait. Shilpi has done it.
Can you please repeat?
Done it? Okay, I'm going to show the next step now. Any doubts in this step? All I have done is on this black portion, there are 8 white dots. We have made holes in all those white dots using a toothpick. Okay, now I'm showing the next step. Please do have a look at the screen. Now, once again, we need to fold it. As soon as you will fold it, you will start getting the shape of a box. So to fold it, I hope you see the red lines or wherever the solar panels, they're attached together. That's where you need to fold them from. You see, the outer body of lander has got so many solar panels on it. It needs all of this. While we are talking about it, I missed one point. You see, this mission, when it lands, it is going to work for 1 lunar day. Okay, just 1 day of the moon it will work. But do you know how many Earth days is it? On moon, if you live, it will be just 1 day and night. But on Earth, it will be 14 days. Okay, so it is going to work for 14 Earth days. When it reaches there, that's how long this will be. Atharv, done? Just relaxing and chilling. Are we done? Folding? Oh, good. Very nice. I hope you all have folded it. As soon as you fold, you will know what to do. Yep, let's see. First up, we are going to make a box down below here. You see this bigger portion on one of the sides is this white flap. We will bring the other side and overlap on it, just like we did on the box. Okay. The longer side that was there on one of the side, there is a white part coming out. That's where you will apply the glue. Bring the other side and overlap it on the top. Okay. It will look something like this. That is shown in the image. I'll play the video once again for any confusion in this step. So in this, after folding, we see this longer side where the fingers are running right now. That's the longer side. On one of the sides, the white pop out is there. We'll bring the other side and overlap it on top of it after applying glue. I hope you are able to understand. Okay, good. Many of you are done there also on the participants on YouTube. Sunat has said, does it have a solar panel on its side? Yes, it does have solar panels. Who all are done? Let's see. Yes, Archana, you're saying 14 days is the duration of Chandrayaan 3 on the moon. That's correct. 14 Earth days. Okay. And in that duration, the exploration, the objectives needs to be covered. Okay, good. Athar, Arshdeep, very good. Others, how about everyone else? Are we done? Very good, Advay. Good, Parth. Karthik, done? Okay, Suhani, how about you? Okay, very good. So as soon as you do this, all you need to do is close from the two sides which are open. Okay, so just like we close the box, that's how we are going to close it. These white flaps that we have folded, that's where we will apply some glue and insert it inside. These white flaps will not be outside, it will be inside like this. So hurry up and stick it from both the sides. If you're using sellotape, just insert it and put one small sellotape on the three sides. You don't need to use longer sellotapes to run all along. Just three small sellotapes, that will do. Yeah, yeah, good, Archana. That's correct, what you have written on the chat. How many of you here had followed Chandrayaan 2 mission? Let's see. When it was getting launched, were you all watching it that time? Okay, some of you were. Good. Yes, Sunhat, Chandrayaan 3 will be on 14th of July and the launch time is 2:35 p.m. that day.
permission दिया charger पे लगा के?
Are we done? Closing it from the both the side. Very good, Manan. That's great. Okay, Karthik, go ahead, work on it. Shilpi ma'am has also done it. Very good. Do you all see the door on the lander? On one side, there's a door design. Yes, that's the kind of a ramp that opens up on and the rover works on it. So as some of you are doing, let's see who can write one of the objectives of Vikram lander in the chat. One objective will do. What was the objective of Vikram lander? Okay, good. Arna and Manan have tried there. Decrease the speed. Advais saying soft landing. Very good. Samiksha. Good. Very nice. All right, now I'm going to show the next step. Please follow along. If you are not done, do watch the step and you can finish it later. Now, once we have done this, once we have closed the box from both the sides, remember on one side we have made those holes. That's where we will be attaching the legs of the lander. Okay, the legs of the lander are equally very important because it helps it land on the surface. When you're landing with speed, there's a kind of shock also that you feel. Okay, so all that has to be absorbed by the leg design. So let's see how are we making the legs of our lander. We'll turn it to the back side. You see that you take a toothpick. A toothpick has got a sharp side and a non-sharp side. Insert it from the non-sharp side inside the hole. Okay, like this. The second one also you insert in the second adjacent hole. Take the sharp ends of the toothpicks together and attach a small clay ball there. Okay, this is how you have to attach the leg. Once you have done this, attach all the legs in a similar way. I'm playing with the video once again. We will invert the lander, take a toothpick. Now insert the toothpick in one of the holes from the non-sharp side, which is the blunt side, inside one of the white holes. Insert the second one adjacent to it. Take the other sharp ends of the toothpick and insert a small clay ball to attach them together. In a similar way, you have to attach all the legs of the lander. So let's see if your landers will stand properly after making or not. You will see Chandrayaan 2 lander had some problem. Anyone who has done it? Near the legs of the lander that you have attached, you can apply a little bit of glue later so that it dries off and the legs stay over there. Otherwise, if you will invert it, sometimes the toothpick can come out. If you apply a little bit of glue, give it some time to dry off, it will stay there. See, the paper model is taking so much time. Imagine how much effort goes in making the real model. Wow, very good, Athar. Is your lander standing properly? It can withstand the high velocity, will it? Oh, wow. Athar is showing me also. That's great. Dakshit done. Okay, I see some of you are saying very easy.
sir.
All right. Now we have to attach the lander to the orbiter. Let's watch one final step. To attach it, you can use sellotape or glue, whatever you prefer. I'm showing you with double-sided tape. On the top circle part of the orbiter, I have placed one tape. And I'll take the lander and the lander will stick on top of it. Okay, you can see on the side how does it look once done. This is how the entire model of Chandrayaan 2 was. The lander was on the top, the orbiter body was below, and it was a detachable model. The lander could detach. The Chandrayaan 3 is very similar to it. Below portion, instead of orbiter, the orbiter is changed by a different kind of module. Anyone who remembers what is this module called? Let's see. the bottom portion, which is this module in Chandrayaan 3. In Chandrayaan 2, it was generally called orbiter. In Chandrayaan 3, what do we call this base part?
It's already coming,
Propulsion.
propulsion model.
Very good, very good. Many of you have written. Good that you all remember. That means you all were paying attention. So this is our Chandrayaan 2 model. And I will just take some pictures. Okay. Yeah, those who are done, please show your models to me. Let's take a group picture. Whatever is done, you can show it to me. It's fine. You can finish it. Great, great, wonderful. On my countdown, everyone, let's get ready. 3, 2, 1. Shout out astronomy at your places, or shout out Chandrayaan 3 at your places. That's better. 3, 2, 1. Chandrayaan 3. Awesome. Very good. Wonderful job, everyone. I hope you all enjoyed learning about Chandrayaan 3. Keep your eyes up. We wish all the best to ISRO with this upcoming mission. And I would like to hand it over to Mila ma'am and Prerna ma'am if they have to add on or any questions that are to be addressed. So over to you.
Thank you, Aryan, for explaining such beautifully about the detail of all the missions, lunar exploration done by India ISRO. And also, students, I would like to add that by making all these DIY models, it is to give you that sense of belonging with how special such missions are. So now you have created your own Chandrayaan. So you are probably more excited and you're very much connected to know what the ISRO will be doing on 14th. So are you guys excited? Yes, I can see thumbs up. So we really hope that you do check online because web links are available to check the launch. Even in Nehru Planetarium, we are planning a one dummy version of Chandrayaan 3 model. So we'll be putting it as a display. Also one special show on moon. We are planning to show it. So any chance if you are planning to come on Nehru Planetarium on the day of Chandrayaan launch, you'll be getting all this. Even I request everyone to share the images, pictures of the dummy model you have created, because then I'll tweet on our social media handle so that all the government officials should see what lovely models our budding minds have created in this mission, and also the best wishes for ISRO. So Mila ma'am, anything you would like to add?
I would like to say thank you everyone for joining, and we are all excited about this Chandrayaan 3. So some of you who are asking, you can join our club on this platform, and that would give you access to some live videos. It's a free joining. You can join us, and here's some contact points because some of you are asking on YouTube. So feel free to contact us. And again, thank you, Prerna and Nehru Planetarium, for giving us this opportunity to interact with so many students. And all these students here today have such wonderful questions, and they were constantly giving the right answers and interacting. So they have a lot of knowledge, and very happy to see that you're all so interested in space, and do keep engaged with us and with Nehru Planetarium. We are always bringing you such kind of webinars. So do keep exploring space.
Yes, definitely. And anything, because I think it's already, we are done with the time,
Right.
ma'am, you can quickly share the link of the YouTube so that many of the students who can refer it for the later references can save it.
Yeah, let me quickly do that. Yeah. So yeah, if you want to see the activity, then we still have it there. Okay, so let me quickly do that. 1 second. Yeah. Okay, so I've shared the YouTube link. You can all just copy that, and that would show you, you can repeat what Aryan sir has done on that.
So you
So-
can refer it for the later purposes, as
Right.
anyone who missed any kind of a step. Also, I'm mentioning Nehru Planetarium's email ID. So you can share the pictures of your model by holding it with your picture as well. So we can post it on social media. Also, if you have anything, any doubt, anything related to the session, feel free to ask it on the email ID. So I think with this, we'll wrap today's session with a lot of excitement and enthusiasm for the coming launch of Chandrayaan 3. So thank you, Aryan. Thank you once
Thank you
again.
so much.
Thank you, Mila ma'am. And I would also like to thank the entire team of STEM and Space for doing such a great work in this field and making astronomy and space science popularizing in children and youth. So really would like to collaborate for such workshop again in future. And I would also like to see all the budding participants who are available with YouTube as well as on Zoom platform to come and visit Nehru Planetarium. If not, so do get connected with us on all other platforms, like all social media webinars, online things, we are doing it so that we can get better understanding in this area. Thank you, ma'am. Thank you, everyone. Do take care of yourself.